Hero's Journey in Mechanics, written and narrated by G.V. Pavan Kumar. Part 1. Introduction. The Greco-Roman era, which extended across various parts of Europe and Egypt, had a profound influence on the development of knowledge and architectural construction. During this period, there was a notable interaction between manual labor and intellectual inquiry, culminating in the emergence of mechanics as a significant domain of human knowledge. While written text often addressed mechanics from an abstract perspective, construction activities and the use of small mechanics embodied their practical applications. Take, for example, the lever, a device with direct practical utility in a wide range of contexts. A deeper exploration of such a device reveals foundational concepts in mechanics and mechanical engineering. This established an important two-way relationship between abstract theory and practical implementation, a mode of thinking most clearly exemplified in the works of Hero of Alexandria. Hero's writings were closely linked to mechanics and mechanical engineering, and the knowledge he produced spread across Europe and the Arabic world. He was deeply influenced by Archimedes, frequently referencing his work across multiple treatises. In doing so, Hero consolidated earlier knowledge and repurposed it for a variety of mechanical applications. He is also credited with creating what is now considered one of the earliest forms of the steam engine using a simple pneumatic device. He was also indirectly influenced by Aristotelian thought. Traces of Aristotle's Mechanica can be observed in Hero's approach and conceptual framework. A central feature of Hero's work lies in the foundational principles through which he analyzed mechanical devices. Specifically, he focused on 5 fundamental mechanical elements: the wheel and axle, lever, pulley, wedge, and the screw. Hero sought to relate these devices to a core geometrical principle, the circle, and further connected them to the concept of balance. This integration of geometrical abstraction with practical devices was at the heart of Hero's methodology, making him one of the earliest thinkers to approach mechanics as both a physicist and as an engineer. Another significant aspect of his work is his use of models, which provided new insights into the operation and design of mechanical systems. During that period, understanding how large weights could be moved using relatively small forces, such as through the use of a lever, posed a conceptual and practical challenge. Addressing this challenge led to deeper investigations into balance and the principles underlying mechanical advantage. At the center of these intellectual developments was Hero of Alexandria. His work exemplified the dual nature of mechanics as both an intellectual pursuit and a practical tool. Hero's influence helped shape the treatment of mechanics as a cornerstone of ancient scientific and technological achievement. In many ways, he unified physics and technology on a single conceptual platform, offering a distinctive way of understanding natural phenomena and applying that understanding towards practical ends. Part 2. About Hero. Hero's time and place will be central to this discussion. Let us now examine the details concerning Hero of Alexandria. As with many ancient historical figures, it is quite difficult to determine the exact dates of his life. However, there is a general scholarly consensus that he lived sometimes between the 1st and the 2nd century CE in the city of Alexandria located in the present-day Egypt. During this era, Alexandria was under the rule of Greek authorities, and the period is typically characterized by Greco-Roman influence, often referred to as Hellenistic period. Interestingly, one of the methods by which Hero's era has been dated involves a lunar eclipse recorded in his book Dioptra. This particular eclipse occurred on March 13th, 62 CE, and scholars think this observation provided a useful temporal marker for situating Hero in the history. Little is known about his personal life aside from the fact that he lived and worked at the University of Alexandria. This conclusion is largely inferred from the numerous books he authored, which corresponded closely with the scientific and technological knowledge of that time. With regard to the intellectual influences, it is clear from his writing that Hero received a thorough education in Greek literature available up to that particular period. In particular, his works frequently reference those of Archimedes. There is also an indirect influence of Aristotelian thought, although explicit reference to Aristotle are less common than those to Archimedes. It is important to note that Archimedes' contribution has a profound influence on scientific thought for generations, and Hero of Alexandria was no exception. What is particularly fascinating about Hero is that he not only demonstrated a deep understanding of Archimedean work, but also possessed considerable knowledge of devices and simple machines available in this time. Alongside these intellectual currents, Hero was also influenced by Ctesippus of Alexandria. His writings exhibit a connection to this earlier Greek scholar, and some scholars even speculate that Hero may have been a student of Ctesippus. It is worth noting the transmission of influence from older scholars to later ones was largely facilitated through published works. Given that the University of Alexandria was a renowned center of learning, it is unsurprising that Hero of Alexandria was familiar with the work of many earlier scholars. Part 3. His books, mainly related to Hero's published works. From the existing literature, Hero of Alexandria is associated with 14 texts, of which 8 are directly attributed to him, while 6 other works are associated with him with less certainty. Among these works, his book on pneumatica, metrica, and mechanics have garnered significant attention. In the context of pneumatica, the subject pertains to pressure of air, water, and steam and their applications for various purposes, including entertainment. Mechanica, of course, covers simple devices and machines, and this work is primarily preserved in the Arabic language. It is generally attributed to a few scholars from a later period. There is also an interesting piece of work titled Automata, in which automatic machines of that time are discussed in the context of mechanics and the associated engineering. It is the metrica that is associated with the calculation of volumes of various solids and certain planes and surfaces, which has drawn considerable attention and has become a well-known source of information. Of course, Hero also worked on war machines, and this particular work is available in Greek. The lifting of weights was a major technical challenge during that era, and Hero of Alexandria naturally approached this problem from the standpoint of mechanics. Many of his works, including Pneumatica and Mechanica, contain elaborate discussion on various forms of weights and the techniques for lifting them. This obviously is associated with the engineering tasks necessary for constructing the architectural works of that period. Another interesting aspect of Hero's work is associated with geometry, especially through the work titled Geometrica. He has also investigated calculations related to three-dimensional objects, which show a close connection to measure principles relevant not only to devices but also to surveying landscapes and measuring distances, including those associated with human constructions such as tunnels. There are a few works associated with definitions of mathematical entities, and their attribution remains debated. Nevertheless, all this evidence indicates a prolific intellectual life of Hero of Alexandria, and many scholars attribute this productive authorship to his position as a teacher at the University of Alexandria. For example, if one examines certain works of Hero, such as Pneumatica, the instructional style is in such books appears to resemble manuals for students to gain an overview of devices. Also, the discussions are not very terse, and many scholars interpret this as a recap for students who are advancing their knowledge in mechanics and related phenomena. It is noteworthy that the entire body of work suggests that Hero of Alexandria not only had a strong command over mechanical machines, but also possessed the ability to think in abstract terms. This is evident from his writing related to mathematics. Such a combination of application and abstraction is one of the most significant features of Hero of Alexandria. Part number 4. Pneumatica. Now let's look at some specific works of Hero of Alexandria, beginning with Pneumatica. The word pneuma means wind in Greek. The adjective essentially refers to something that contains or operates using air or gas under certain pressure. In this context, Hero's Pneumatica describes various aspects related to the utility of air and gases for mechanical motion. The theme of this work is fascinating because it is not an abstract or a purely theoretical exposition on mechanics or just conventional mechanical engineering. Rather, it is a direct connection to small devices used for a variety of purposes, including entertainment. Among these are descriptions of several toys such as birds that sing, coin operated machine, and what is probably the first vending machine recorded in the literature. Among the many devices discussed, the one that has particularly captured the attention of historians of science is the device called as heliopile. This is considered a prototype of earliest steam engine as you see in figure 1. It operates using steam generated by boiling water in a kettle. The kettle is connected to a sphere with two nozzles. When the water boils, the steam enters the sphere and causes it to rotate. The key aspect of this design is that the sphere is connected to a horizontally placed shaft. As the steam exits the nozzle, it causes the sphere to spin, thereby converting the thermal energy into mechanical motion. This device has drawn the attention of many historians studying the origins of steam engines, as it represents one of the earliest known examples of the thermal to mechanical energy conversion. The book itself contains fascinating description of miniature devices adapted for various uses, including magic shows and theater productions. Unlike some of Hero's other writing, Pneumatica reads more like a manual for operating small devices with concise and practical description rather than theoretical elaboration. The quality of the diagrams in this work is particularly notable and has attracted considerable attention from historians. One of the best known surviving translations of this work is by Englishman named Bennett Woodcroft, which was published in 1851, as shown in figure 2, the title page. This translation has become a standard reference for scholars seeking to understand the nature of Hero's contribution. It highlights Hero's particular orientation, and it also indicates his practical aspect of the work, which is quite distinctive among scholars of his stature. In comparison, the work of Archimedes and his immediate followers are generally more rigorous and focused on mathematical applications. Most of them do not discuss simple or seemingly trivial devices in the manner that Hero does in Pneumatica. Nevertheless, it is important to emphasize that Hero was deeply influenced by Archimedes. Many of the devices described in this book are based on principles associated with Archimedes and his pioneering work. This is characteristic of Greek scholars who regarded Archimedes as one of the earliest scientists to understand the natural world through systematic mathematics and physical models. In some of Hero's other works, one sees this intellectual lineage in action, combining abstract analysis with practical application. This synthesis of theoretical and applied thinking positions Hero as a pioneer in engineering mechanics. Many of the devices he designed continue to be of great interest to both engineers and artists. In this light, Pneumatica offers a compelling insight into Hero's intellectual curiosity and his pedagogical intent, particularly in presenting devices to students through detailed and accessible instruction manuals. Part 5. Mechanica. Next, let us consider an overview of Hero's book titled Mechanica. This work comprises 3 volumes, and the surviving text is available only in Arabic translation. Some scholars believe that the content may have undergone certain alterations during the process of translation and transmission. One of the earliest references to Mechanica dates to around 300 CE, made by Pappus of Alexandria in a discussion on heavy weights and the methods used to lift them. The book is strongly grounded in principles originally proposed by Archimedes. It presents several mechanical principles with a degree of abstraction. The concept of the balance, its theoretical foundations, and its relationship to various mechanical devices such as pulleys, screws, and the wheel and axle are discussed in considerable detail. A distinctive feature of this book is its treatment of the transportation of heavy objects using mechanical aids, as well as the application of the concept of the center of gravity to various solid forms and shapes. The text includes a significant degree of abstraction and presents a theory of motion too, that provides insight into Hero's understanding of mechanics and mechanical engineering. In this work, Hero refers to Archimedes as many as 10 times, indicating a deep intellectual depth. Moreover, scholars have observed that Hero's approach is indirectly influenced by Aristotelian perspective on mechanical motion. A notable aspect of this book is its emphasis on connecting abstract mechanical principles with practical applications. Devices such as the lever, pulley, wheel and axle, and various forms of screws are examined in depth. In this respect, Mechanica can be seen as an early treatise in engineering physics, serving as a key reference for understanding ancient mechanics and mechanical engineering. The book's content also reflects the context of the Hellenistic period, which was marked by elaborate construction projects. The principle and techniques discussed in Mechanica have potential relevance in these large-scale engineering efforts. Finally, Mechanica exhibits strong intellectual continuity with Hero's other works and shares conceptual commonalities with a few additional sources. This cohesion underscores Hero's broader contribution to the understanding and development of mechanics in antiquity. Part number 6. Other works of Hero of Alexandria. Let us now consider a few other works of Hero of Alexandria. First among them is Metrica, a collection of 3 books and arguably the most well-known of his works. This text is primarily concerned with measurement and geometry and includes an elaborate discussion of what is now known as Hero's formula or Heron's formula, a well-known result in elementary geometry for calculating the area of triangle given the length of its sides. Metrica also explores the computation of square roots using iterative methods, a topic with significant application in basic mathematics. The work focuses on the ability to perform measurements, including the calculation of the volumes of solids such as Platonic solids and other fundamental geometrical shapes. Ratio from another important aspect of solids are also discussed in this particular book, with very specific computations of arbitrary ratios of various different geometries. The next important work is Dioptra, which deals with the measurement of length. It includes a discussion of the instruments known as the dioptra, which is directly related to the surveying instrument that continues to be used in modified forms even today. An interesting section of this work also discusses the odometer, a device used to measure the distance traveled by a moving object. This provides one of the earliest known references to such a device and highlights Hero's interest in practical instrumentation. Another fascinating work is the Automata, in which Heroes discusses automatic machines in great detail. This text is associated with the domains of magic, theatre, and mechanical marvels that were designed to captivate observers. There is extensive discussion on automatic doors and related architectural mechanisms, which were likely employed in temples or public spaces during Hero's time. The work also includes ingenious systems for pouring and transporting liquids automatically, illustrating Hero's advanced understanding of fluid mechanics and automation. Taken together, these works reflect the rich intellectual repertoire of Hero of Alexandria. At the core of all his writing is a deep engagement with mechanics approached with abstract and practicalities. In this light, Hero's contributions are of immense significance, offering valuable insights into the interplay between theory and application in ancient science and engineering. Part 7. Conclusion. Hero of Alexandria embodied ancient human thought process that mixed physics and technology for intellectual and practical purposes. In a way, he laid the foundation to harness mechanics for practical application and built on ideas proposed and utilized by great thinkers such as Archimedes and his followers. It is quite remarkable that a person of that era could come up with such interesting innovations for not only practical applications, but also for teaching and demonstrations for the public. Credit should also be given to the followers and students of Hero, who took his work forward and spread it across the world. Perhaps that is the best way to leave a legacy, by learning, creating, and sharing knowledge. You are listening to Essays in Global History of Physics, written and narrated by G.V. Pawan Kumar as part of podcast Pratidhwani Humanizing Science. All the episodes, including the references, are freely available online at historyofscience.in. Do check the description for the link. Until next episode, Keep exploring physics, history, and philosophy. Bye bye.